Okay, problem number 5. The volume of a spherical hot air balloon, spherical meaning sphere, expands. So the balloon is getting bigger. It's always better to write things than just to read. Like it slows you down. Just kind of think about it. Okay, so I've got a spherical balloon. The balloon is getting bigger. The radius of the balloon in feet, units are always going to be tested. It's modeled by the twice differentiable. That word is often not important, but just in case, of r. So slow down, the radius of the balloon is r. So this is r prime. So this is a rate, feet per minute. If I were doing Danica's chart, I'd have the amount is r. The rate at which the radius changes, that's r prime. Okay. Time interval 0 to 12, that's usually pretty easy. I don't usually have trouble with that. The radius of the balloon is, this is important, the radius of the balloon is 30 feet when t equals 5. So r of 5 will equal 30. Once again, keep writing things. It always helps. Then they give me a formula that I will definitely use somewhere. Estimate the radius of the balloon. So estimate r at this time. So I'm trying to find r. Keyword estimate. Using the tangent line approximation at t equal 5. Okay, as soon as I read that, I know I'm going to be using this picture. The curve is going to be r. So this picture makes sense because r is going up. R is getting bigger. Oh, but it says right here r is concave down. So a more accurate picture would be something, oh no, actually this is fine. So this is r being concave down, so we're good there. You're supposed to use this tangent line. So here's the equation for that. So to use a tangent line, I have to find the tangent line. Notice how I did not keep reading. They're going to give me multiple points for this problem. I want to just do them one at a time. I'm not trying to get all the points, just as many as you can. So the point right here is at t equal 5. Hey, here's why this is important. Because at time equal 5, the value of r is said to be 30. So now I need the slope of this line, which means I need r prime at time equal 5. That's why they gave me the table. That's equal to 2. So now I have my tangent line equation, which is y equals the slope of the curve at time equal 5, the slope of the curve of r, that's 2. It's actually dealing with time now, but this would be x minus x1, which is 5, plus y1, which is 30. And I'm supposed to approximate the radius when time is 5.4. So I'm supposed to be approximating r, not r prime, r of 5.4. using this line. The idea is that over here, 5.4 might be here. So that would be t equal 5.4. And whatever this y coordinate is, that would be r of 5.4. But we're going to come up here and find this point on the line tangent at the same time and find this y coordinate, and that is our approximation for this y coordinate. So r of 5.4 is going to be approximately equal to, and there's no need to work this out, you get the full credit. The time we plug in is 5.4 minus 5 plus 30. I should always include units. I'm finding the radius of the balloon. The radius is measured in feet. Okay, I need this red line, I get 1 point. Everything else was just me helping, all the rest was just to help me figure out the red line. The red line is worth 1 point. So I have estimated the radius of the balloon using the tangent line approximation at t equal 5. I've done that. Is my estimate greater or less than the true value? The picture tells me the answer. R is concave down, therefore the actual value of R will be below the tangent line approximation. That's what you have to write. They said R is concave down, so just use what they said. Since R is concave down, the estimate is greater than R of 5.4. If you have those words, must be pretty much word for word, you get the second of the 2 points on part 5A.